Welcome! In this video, we'll look at two methods you can use in Automic to start tasks automatically and on a regular basis. For recurring processes, you're already familiar with the schedule object. But if something needs to run more frequently, for example every few minutes, there are more practical alternatives. The first is called recurring, or also periodic execution. This is a start method, meaning an execution option. The second are events, a separate object type that responds to specific conditions, such as a certain time or when a file appears. Both can be monitored, stopped, or restarted in process monitoring. And both behave similarly. When they're not doing anything, they are in an idle state, referred to as sleeping. I'll show you what sets them apart, when you should use which one, and what in the world all this has to do with the automated cleaning of a toilet. Because my example takes place in a shopping mall. There, the cleaning robot Cleanus 2000 keeps things tidy. Regularly, reliably, and of course fully automated, controlled by Automic. You can spot recurring tasks, also called cyclical tasks, in process monitoring by their type C period, which is also sometimes called a period container. Execute recurring is an execution option. I select the object and start it using execute recurring. Now we see a dialog window. In the first section, you can load a period object. Period objects store the execution settings, but more on that later. The execution settings are self-explanatory. Under period, you can select a start date and specify when the recurring execution should end. Now comes the most important section. Frequency. There you'll see three options that allow you to configure how often the recurring execution should run. With the first option, execute at, you can set a specific time. By default, the allow one overlap setting is deactivated. So if the task from the previous run is still active, it will not be started again. This restriction only applies to execution started by the same period container. And if you check the box, you allow exactly one parallel execution, no more than that. Then, using the second option, you can start a task at a given interval. For example, maybe every minute, every 3 hours, or something similar. And here too, you can allow one overlap. Additionally, you can set up a time window during which executions are allowed to run. The option adjust initial start to a clock time interval uses the previously configured time window to determine the start times. An example would be a time window starting at 2:15 p.m. at an interval of 10 minutes. This way, its start times are 2:15 p.m., 2:25 p.m., 2:35 p.m., and so on. The third frequency option allows you to define the waiting time between executions. Only after one execution is finished will the next one start, following the set waiting time. In the last section, you can define the days on which the execution should run, either daily, on specific weekdays, or with a custom calendar condition. Now let's go back to the first section, the period settings. I've now set a few things below. If I now select a period object, the settings I made below will be overwritten with the values from the period object. It's important to know that the settings are just copied from the period object. If the designer later changes the period object, it will have no effect on the active period container. The description field adopts the title or name of the period object, but it can be overwritten. By the way, this job here checks the feedback left by the restroom visitors every minute within the set time window. If the feedback is negative, it creates a log file. I click on execute to start the thing. In process monitoring, we can now see the cyclical task with the regular feedback check. The description field contains the title or name of the period object used. And the task type is C period. So this is not a running job, it's the period container. Next to it, we see another C period object that's already active. In the detail window, we can see how many times this workflow has already been started and when it will run next. Let's take a look at the child tasks. Here we see all the small cleanings that have been started by this period container. The parent run ID is always the same here. That's the run ID of the C period. Makes sense. Back to process monitoring. Since we just talked about the run ID, even if the container keeps running indefinitely, the run ID actually does change from time to time. By default, every 14 days, but this can be configured by the admin. In the context menu, you can pause, also known as suspend the period container or restart it if it is paused, or stop it with the quit option. Now I'm going to open the settings. Here we can see that the small cleaning is started every hour. The start time is adjusted to the time window. You can see this very clearly in the report. The execution always takes place at the full hour, even though the period container itself was not originally started exactly at a full hour. And by the way, you can only view the settings for C periods that are active. Once a C period is ended, you can no longer check which settings it was running with. An alternative to period containers are event objects, or simply events. And unlike recurring executions, events actually are executable objects. We'll take a look at them in the final section of the video. There are several subtypes of event objects, though from the operator's perspective they all behave very similarly. For controlling the Cleanus 2000, we only use two types: time events and a file event. With a time event, we start the big cleaning every 3 hours. We could have used a period container for this as well, but we didn't. The event is already active. Just like a C period, it usually runs indefinitely and also receives a new run ID every 2 weeks. In the details window, we can see that it has already triggered an execution once, and also when the next execution is scheduled. Let's take a look at the child executions. They belong to the !event type. Whenever the event occurs, this !event is executed. It can contain any Automic scripting commands, but in our case, it executes the big cleaning workflow. We can see that if we go one child level deeper, then the second use case for a time event inside the Cleanus 2000 is a time delay within the big cleaning workflow. The event object gives the disinfectant 1 minute to take effect. So as you can see, time events can also be used within workflows to introduce delays in necessary places. Now let's move on to the file event. The file event itself can be started like any other executable object, but this one here is already active. In the previous section, we started a period container that checks customer feedback every minute. If there is negative feedback regarding the cleanliness of the toilets, it writes a log file. This file event waits for such log files. Then, once it locates a fresh log, the file event sends the Cleanus robot to perform a small cleaning. Here we can see the active file event. In the detail window, we can also see that it has already found matches several times. Since the start of this execution, it has checked 20 times and has already found a result 9 times. Accordingly, we find 9 child executions that belong to the !event type. And underneath each of those, there is an execution of the small cleaning run. You can easily stop, restart, or end any of your currently active events at any time you wish, whenever you need to, just like it is with period containers. Now, time for a brief summary of the differences. C period is a start option that allows a job or workflow to be started regularly. Event is its own object type that triggers something when a condition is met, such as a specific time or a file. Both run continuously in the background, both appear in process monitoring, and both can be stopped or restarted. The main difference lies in the trigger. C period follows a fixed schedule. While an event responds to an occurrence, and events can not only be used on their own, but also within workflows, for example for delays or waiting conditions. That brings us to the end of the video, but we're not quite finished yet. Now do the exercises and try out the examples yourself, because the best way to learn is by trying things out on your own.